Okay guys, we're working on Chapter 6 Review Quadratics. This is one of two packets you're going to get to review for this big test on quadratics. Remember that you can use your factoring foldable, so please have it next to you. I'm not going to do every problem, I'm just going to pick a few from each group so you can kind of notice the patterns here. So let's start with question 1. Determine the direction the parabola opens. Well, if you look at question 1, it's all based off the lead coefficient. In this case, it's a positive 1. It's not written there, but it's there. It's positive, so that means that the opening direction must be up. Remember, you can describe it as lead coefficient equals 1, or you could say it is positive, however you want to describe it. Okay, questions 3 through 7, 8 are all based off factoring. Okay, and the first thing you have to do is tell me if it's an expression or an equation. If it is an equal sign, so if it's equal to something, then we know it's an equation, and if it doesn't, then it has to be an expression. Okay, so you can actually quickly go through. The first one's got to be an equation because there's equal sign. The second one's got to be an expression because there's no equal sign. And I actually wanted to do question 4. Okay, the reason being is because this is one of our more difficult factoring questions, because the lead coefficient is not 1. Okay, so remember the first steps, you have to multiply a times c, which gives me 30, and you have to find a numbers that multiply or add to the middle term, which is negative 13. So the two numbers that do that are going to be negative 10 and negative 3. Okay, some people want to think 15 and 2, but remember it has to multiply to a positive 30. So because that would multiply, adding to a negative 13, it'd have to be negative 15 and positive 2, and that would not multiply to a positive 30. So it's got to be a negative 10, negative 3. So I'm going to rewrite the first term and split the middle term into those two numbers that we just found. Rewrite the last term, and then I can factor by the grouping. Okay, group the first two terms together, factor out a GCF. Well, 2 and 10 both have a 2. X squared and an x, well, I can only take one x out of there. The first term I'm left with x minus 10 divided by 2 gives me 5. And now let's take the GCF out of the second two terms. I always want to take that negative out if there's a lead coefficient that's negative. And then 3 and 15, well, they share 3. I'm left with an x, and then because I factor out a negative from a positive, it's x minus 5. And if you notice, we have the same thing in parentheses. That's our goal. That's good. So now if I factor out that x minus 5, and then whatever's left in the parentheses, or outside the parentheses, is our next set of groups, or factors. So 2x minus 3. Okay, so factored form is x minus 5 and 2x minus 3. Okay, well, let's take a look at some other problems here. It says the solutions if necessary. Well, because it's not an equation, we actually do not solve for x, so we do not have any solutions there, so you can put a little x through it. Now let's try another one. I for sure want to try number 5 because it looks a little different from everything else we've done. You always want to start with GCF, but x squared and 121 do not have a GCF. So one thing I like to do with these problems is I like to rewrite the middle term. Right? There's no x there, so what does the coefficient have to be? Well, it has to be 0. Okay, so now it looks like every other quadratic we have, with an a being 1, b being 0, and c being negative 121. So what are two numbers that multiply to c? So they multiply to negative 121, and they add to 0. Well, if they add to 0, they have to be the positive negative of each other. And the only number that multiplies to 121 is 11. So it's got to be positive 11 and a negative 11. So there's my factored form, positive 11, negative 11. And the solutions, well, it's still an expression. So there are no solutions. Let's pick one more here. Let's try maybe number 6. It looks a little different from everything else. Well, first thing for sure is that it is an equation and it has an equal sign. And now we have 2x squared minus 10x equals 0. Well, if you look at the form, there's no c, there's no constant. So that means I can use GCF. And there is a GCF between 2x squared and 10x. Well, 2 for sure, and an x. And then in the first term I'm left with x, the second term I'm left with x minus 5 equals 0. Well, these are my two factors. Remember, once you have factored form, you can use the zero product property and set them equal to 0. So 2x equals 0 and x minus 5 equals 0. Solve for x. Divide by 2, divide by 2, plus 5 plus 5. So I get x equals 5, and 0 divided by anything is always 0. So my two answers are x equals 0, x equals 5. And the factored form was actually from this step right here. So I got 2x and x minus 5. Okay, so you can finish up those factoring terms. Make sure you're using your factoring foldable for the last few problems. Let's try slide number 2. Okay, well, slide number 2 looks to be a little quicker here. Label the points of the graph using the vocabulary from this chapter. Also state the coordinate pair. Well, remember that a maximum or minimum where it changes from increasing to decreasing or decreasing to increasing, that was called the vertex. And the coordinates start with the x over 2 and then up 9. So 2 comma 9. The next two, well, if you look at where they intersect at the x-axis, so that's called an x-intercept. The two coordinates are -1, 0, and 5, 0. Remember, they always have to have a 0 as the y value. And then the last one right here, well, if you look, it intersects the y-axis, so it's got to be called the y-intercept. Okay, well, the coordinate x-intercept has a y value of 0, so the y-intercept has an x value of 0, comma 5. There we go. Okay, John is solving the equation below. Step 1. Well, we have an equation, and remember that when we're solving by the square root property, we have to undo PEMDAS. So let's figure out what we have here. P-E-M-D-A-S. Undo means starting from the bottom. Well, the first thing he did was, starting from the bottom, addition or subtraction. Well, he for sure subtracted 3 from both sides. So next we got to keep working on multiplication division. So I have to divide by 3 from both sides. And if I do that, I'm going to get x plus 1 quantity squared equals 9. Well, let's find that over here. There we go. So that's got to be the next step. Okay? You cannot distribute the squared and you cannot distribute the 3. Okay? You absolutely could do what you needed in step 4, but I promise you it's going to be a waste of time. Okay? So actually either one does work. Step 3 or step 4, but step 3 is in the right direction. So now I have x plus 1 quantity squared equals 9. What being squared is by itself, so I can square root both sides. So I'm left with x plus 1 equals positive 3, and remember you always get two solutions. So x plus 1 equals negative 3. And now just solve. Subtract 1, subtract 1, subtract 1, subtract 1. X equals 2, and x equals negative 4. Write the equation for the quadratic formula below. Pay attention to your signs. Well, this is in your factoring foldable. Okay, it's right in the end. Okay, solving quadratics, the last page. So it's x equals, let me zoom in so I can get some more space here. Opposite of b plus or minus, because there's always two solutions, the square root of b squared minus 4ac, all divided by 2a. Okay, let's try step 3. Solve the equations to find the zeros using the method stated. Well, square root property is flip to that page on your solving quadratics page. I need to isolate what's being squared, so let's divide by 4, divide by 4, so x squared equals 16. Now what's being squared is by itself, so I can square root. So I get x equals positive and negative 4, always two solutions. Okay, quadratic formula, here we go. 2x squared plus 5x. Remember that we have to have it equal to 0 to use the quadratic formula. So I need to subtract 8 from both sides. Okay, so now I have my a, my b, and my c. So a equals 2, b equals 5, and c equals negative 8. So I'm going to zoom in a little bit, give myself some space. Here comes the quadratic formula. X equals the opposite of b, so negative 5 plus or minus the square root of b squared. So 5 squared minus 4 times a, which is 2, times c, which is negative 8, all over 2 times a. Here we go, negative 5. You always simplify what's inside the square root first. 25. Well, this is a, let me focus in right here, negative 4 times a negative 8, so it's got to be positive. So we get 4 times 2, which is 8, and 8 times 8, which is 64. Remember, it's positive, so it's plus 64. All over 2 times 2, which is 4. X equals negative 5 plus or minus the square root. Well, 25 is going to give me 80. 5 plus 4 is going to be 9, so 89 all over 4. Well, 89, we're trying to simplify the square root of 89. I don't want decimals. I want to keep it in factored form or simplified form. So are there any perfect squares that are a factor of 89? No, I don't think so. So we can actually leave it just like this. Got my two answers. So let's slide down right here. And my zeros are negative 5 plus or minus the square root of 89 all over 4. Zero product property. Well, the only way to get the zero product property is if we factor. So what are two numbers that multiply to 16 and add to negative 8? Well, if it's got to multiply to a positive, it's got to be negative, negative, or positive, positive, but it adds to a negative, so it's got to be negative, negative. I'm going to go negative 4 on this one. So x minus 4 equals 0. Multiply to positive 16, add to negative 8. So remember, I can set them both equal to 0. Well, you're going to notice that you're going to get the same solution twice. That's totally fine because there's 2 of them. So we get our zeros are 4 and 4. Okay, here we go. The last section. So I'm going to do a few of these. Choose only 4, so I'm going to try to pick the 4 hardest ones, and then we'll work through it for sure. What I am going to help you out with is how to notice which page to use on your quadratic solving foldable. Okay, so step 15, let's look at it. Lead coefficient of 1, so that means I need to find 2 numbers that multiply to 2 and add to 6. Well, 2 and 1, not possible, so we're actually going to have to use the quadratic formula for this one. Okay, 16, I want to make it equal to 0, so I need to get negative 3x squared. And then I'm going to add 80 to both sides. So negative 5 plus 80 is going to be positive 75 equals 0. Well, if you look at this, there's no b term. So what that means is that I can use my square roots property. So I'm just writing these down. Then we'll solve a few of them. Let's go here. If I subtract 16 so I can get it equal to 0, I get 1/2 x squared minus 8 equals 0. Same thing, no b, no bx. Okay, so I can actually use square roots again. 18, there's still no bx term, so I can use square roots again. Nice, solving by square roots. 19, it's already factored for me, so I can use zero product property by setting both products equal to 0. And the last one, this one's a tricky one. We haven't seen one like this, but look right here. If you notice, there's an x in each one, so I can factor out an x. I can actually factor out a 3x, because 6, 3, and 9 all have a 3 in common. So if I factor out a 3x, I get x squared plus just an x left, because I factored a 3 in one of the x's, and then minus 3 equals 0, of 2x squared. So now I can actually factor that 2x squared plus x minus 3 equals 0. Okay, because it has an x term, it has an x squared. So let's pick a few of these. I think I want to for sure do 18. I want to show you 19, and I want to show you 20. Okay, so here we go. Let's start with 18 down here at the bottom. Square root property, because there's no bx, so I need to get the whatever's being squared by itself. So what I'm going to do is I'm going to add 3 to both sides here. So I get x plus 2 quantity squared equals 81. And now whatever's being squared is by itself, so I can square root both sides. So remember, I always get 2 solutions. So x plus 2 is equal to plus or minus 9. And now I can set up my 2 equations. Equal to positive 9, equal to negative 9. So let's subtract 2, subtract 2, subtract 2, subtract 2. And I get x equals 7, x equals negative 11. Now I'm going to write them in x-intercept form because I know what's happening on the next page here. So it's 7, comma 0, and negative 11, comma 0. Okay, question 19, zero product property. Okay, well it's already factored for me, so I can actually set just both the factors equal to 0 and solve. Okay. Add 2, so I get x equals 2, subtract 2, I get x equals negative 2, and my x-intercepts are here. Perfect. Okay, and the last one, it's going to be tough. I'm sorry that's so big. Let's zoom out a little bit. And now I'm going to move over so I can actually factor this bad boy over here, negative. It's 2x squared plus x minus 3. The factor 3x out front, which is right here, can actually stay there until we're done factoring. It's not going to affect this factorable. So I need to multiply a times c, which is 2, and negative 3, which is negative 6, and b, which is 1. Okay, so 2 numbers that multiply to negative 6, probably 3 and negative 2, have to add to positive 1, so 3's got to be positive. Nice. So remember, I'm going to bring down the first term, rewrite the middle term into the 2 numbers that we just found, positive 3, negative 2, and bring down the last. Now we can factor by grouping. Well, 2 and 3 don't have a GCF, but x squared and x do. Let's just take out an x, and we're left with 2x plus 3. Remember, we always take out the negative if the negative is in front of this lead coefficient, which it is. So take out this negative. 2 and 3 still don't, but x again, and we're left with 2x plus 3. Okay, so now, this is kind of scary. Ooh, actually, let's check back here. My bad. right? 2x and 3 do not share an x. There's actually just going to be a 1 there. And now if you notice, they have the exact same thing in parentheses. Good, that's one of our factors. And the other factor is whatever's left, x minus 1. Okay, and now what I'm going to do is I'm going to take this 3x and I'm going to bring it over to the problem, because that's one of our factors as well. And now what we can do is we can set them all equal to 0 separately. So let's slide up so we can get some space here. Okay, so I'm going to set 3x equal to 0. I'm going to set 2x plus 3 equal to 0. Doesn't matter how many factors you have, you always set them equal to 0. Divide by 3, so x equals 0. There's one x-intercept. Subtract 3, so I get 2x equals negative 3. Divide by 2, I get x equals negative 3 halves. And then plus 1, x equals 1. So look up here, let me get some space again. Let's get my x-intercepts 0, 0, negative 3, 2, 0, and 1, 0. Okay, a lot of solutions. I know it's a challenge one, but I promise you can do it. GCF and then use our factoring skills. Problem. Choose two of the problems from 15 through 20 that you solved for to sketch a graph of the parabola. Consider the opening direction of the parabola too. Be sure to label which problem you chose to solve. Okay, so give me a second so I can go back and check which two problems I like to work. Okay, so the two problems that I picked were problem 18 and 19. I rewrote the problems at the bottom with the x-intercepts that we solved for already. Now let's graph them. Okay, so all we need is we need to figure out which direction it opens, up or down based off the lead coefficient, like questions 1 and 2 in the packet, and then we have to use our x-intercepts. So let's start with our x-intercepts here for question 18. 7, 0, so I'm going to plot that right here. Negative 11, 0, it's a little bit off the graph, that's okay, right over there. And then it says using the direction of opening. Well, if I look right here, this coefficient in front of the x, that's going to tell me the lead coefficient. Okay, if I multiply a positive times itself, because remember that's what it means to square something. If I multiply positive times itself, that's going to give me a positive, so it's got to open up. Okay, so here are my x-intercepts. Do the best that I can to draw my U-shape through my x-intercepts, and it's opening the upward direction. Let's go to question 19. Same idea. Let's start with our x-intercepts, negative 2 and positive 2. Okay, if you look right here, it's a positive 1 in front of the first x and a positive 1 in front of the second x. If you multiply those out, you get the x squared, and 1 times 1 gives you a positive 1, so that means it's going to be opening up again. So there are two x-intercepts, and then we can draw the quadratic through the x-intercepts going upwards. Okay, so what you'll notice is we have a really big packet here, a lot of questions, but I promise you guys can do this. Listen to this YouTube video as much as you need to figure out these types of patterns, and then we'll work on all these other problems. Let's get them all done, do the best that you can, use your quadratic solving, and then ask questions when you got time in class. Good luck, guys.